And, sorry. Hi, Algebra 2. Today's lesson is on factoring polynomials, and we've done a lot of factoring, and we've reviewed some factoring, and we're going to review a little more. This kind of has a lot of different factoring in one place. So this worksheet will be for while I'm gone for fourth period, and for second and sixth if you need some, if you weren't here or whatever. The front side of the factoring just has a bunch of instruction on factoring, and the back side has some problems to work. And the first factoring that you always look at is there a common factor that you can factor out of any expression? And for example, 3x minus 12, 3 will go into both of those numbers so that you can factor out a 3. And 3 times x is 3x, and negative 4 times 3 is the negative 12. On this next one, there's x's and y's that you can factor out. So I look for the smallest power on the x, which is an x to the first power. Smallest power on a y, that's the y to the second power, so that will be what I'll factor out. Then I look for any numbers. Nope, 1 and 3. 1's the biggest factor. And then x times y squared times what will give me x squared times y squared. Okay, got to multiply that by x. Got to multiply that by 3 to get the second factor in here. And then this one's a little different. The common factor is the parentheses part, the x minus y. And so x minus y times 6 will give us 6 times x minus y. X minus y times a will give me a times x minus y. It's always the first thing to look for. Second thing to look for is if you have a binomial. And you may have come up with a binomial after you did this first set of factoring. And a binomial means I have two terms. Two terms. Oh, there's two terms. Here's the first term. Here's the second term. If they are subtracted, we call that difference of two squares. That factoring becomes the square root of each one of these numbers. They have to both be perfect squares. You have to be able to take the square root of both of these numbers. It has to be a subtraction. So I take the square root of both numbers, and I add them and subtract them. And when I multiply them, they'll give me those two numbers squared, and with a minus in between. Perfect square, the variables are all squared, or to the fourth power, or to the sixth power. The numbers are squared, so take the square root. Square root of 9 is 3, square root of x squared is x. Square root of 25 is 5, square root of y squared is y, plus and minus. This is a perfect square. So it turns out to be a perfect square plus the square root of 25, that perfect square a plus b minus the square root of 5. And then they did something a little fancier here. They just kind of took off the parentheses, because a plus b in parentheses minus 5 is just a plus b minus 5. A plus b parentheses plus 5, a plus b plus 5. So, may not have seen that before. Sum of two squares, two perfect squares. If I've got a squared plus b squared, or x squared plus 25, if there's a plus sign, does not factor. You're done. Sum of two cubes. If I have an x to the third power, a y to the third power, I get this pattern. I take the square root, and then I sum, and then I have a squared minus, multiply those two together, plus the square of the second term. So 8 is 2 squared. 27 is 8 is 2 to the third power. 27 is 3 to the third power. I got x third, y third. So my terms are 2x, taking the cubed root of that, and 3y, taking the cubed root of the 27 and the y cubed. and then I plug it into this formula. Take this and square it. 2 squared is 4, x squared is x squared is x squared, minus a times b, 2 times 2x times 3y, negative 6xy, plus the second term squared, 3y squared is 9y squared. And this trinomial does not factor. For subtraction of two perfect cubes, same deal. The formula is just slightly different. The minus sign moves here, and then everything else is plus. The minus sign was in here. Everything else was plus. And it wouldn't be a formula that I would ask you to memorize. And again, the trinomial here does not factor. If you have a binomial, 2 terms, and it doesn't meet one of those, then that binomial doesn't factor. Trinomials. X squared plus 6x plus 9. 3 terms. 4x squared minus 20xy plus 25y squared. 3 terms. Trinomial. It may be a perfect square if the first and last numbers of the trinomial are perfect squares. Then you can check and see if you take the square root, if you get the middle number. Take the square root and double it and get the middle number. So you can check and see if that one is a perfect square binomial. Trinomial, sorry. And it will work out to a plus b squared. So you have to take, these two have to be perfect squares. When you multiply them together and times 2, you get the without the squares, then you get the middle term, then it was a perfect square binomial. Trinomial. Okay. And then there is the trial and error method, or the X method, diamond problem method. 2 numbers multiply to give me 12, add to give me 7, or 3 and 4. So this one factors to x plus 3 times x plus 4, etc. when doing those. And then if you have, we do these at the beginning of the year, if you have a number other than 1 to begin with, you can do a little bit more complicated, and they're not giving us an example here. You can do one a little bit more complicated and use grouping, or you can use trial and error to factor those. And I think you have some examples of those in your book. 4 terms. The easiest factoring is, can you group together two pairs? So, for example, 5a minus, well, no, let's do the x's. X cubed minus 3x squared plus 2x minus 6. I can put together the first 2 and group together the second 2 and find a common factor for the first one. X squared is the biggest number that will go into x cubed minus 3x squared. So they factored out an x squared and times x minus 3. And 2 is the biggest number that will go into 2x minus 6. They factored that out. And then since these 2 were the same, the factoring becomes x squared plus 2 times x minus 3. And then there are a couple of other ways to group. And one way that's sometimes successful is grouping, the first set, if you're in standard form, the first 3 terms or the last 3 terms, and seeing if that is factorable. And then seeing if you can factor again from there. So I think we have maybe one example of that. So now you have a bunch of these to try, which looks pretty daunting here. Except, let me give you some hints. So for problem 1, 2, and 3, you're going to be doing the factoring that I showed on number 1, greatest common factor. And then 4, 5, 6, 7, and 8, those are going to be just like example 2A. 9 is 2C. 10 is a combination of, first you do 1, greatest common factor, and then you can do 2C. 11 is 2D. 12, first you do greatest common factoring, number 1, and then you do 2D again. You do that for 13 also. So double work on the factoring. 14 is just 2D. But you've got to think of this as t to the third power squared. And 15, you'll use 3A. 16, you first have to comment out greatest common factor factoring, and then 3A. 17 and 18 are 3A. 19 is 3B. 20 is greatest common factoring first, and then 3B. 21 is 3C. 22 is 3B. 23 and 24, first you do number 1, and then you follow how they did 3C, and then 3C. And these are all the grouping, all the hard ones. And then 1 and 3B for 28. Number 4, the grouping, when you have the 4 terms, you'll be able to use the grouping, which ends up being a little easier than some of the other factoring that you have to do. You don't have to do all the guess and check. And so that would be 29 to 34. And then the harder trinomial factoring, which is the 3C, the grouping trinomial factoring for 35 through 37. And then 38 is 3A, regular trinomial factoring, and this one's a perfect square. And then 39, you got a combination of doing 2A and then doing 2A again on one of the results. And then 4A works for 40. So good luck. There is an answer sheet online and up at the desk. See you soon.